Hello, good morning students. Today we are going to see about the carbon family, which comprises of the 14th group, and the elements present in the carbon family are carbon, silicon, germanium, tin and lead. I'll repeat: carbon, silicon, germanium, tin and lead. Let us see what is catenation in the carbon group and what are the conditions for catenation. This first element in the 14th group, which is carbon, is found in nature in the native form as graphite. Carbon, as it is represented as C, has the ability to form a long chain of atoms, of carbon atoms. Similarly, silicon also has got a capacity of forming a long chain of silicon atoms. So this ability of an element to form a long chain of atoms is called as a property catenation. Now, for catenation to take place, there are some conditions. So what are the conditions for catenation? The valency of an element should be greater than or equal to 2. The valency of carbon is 4, silicon is 4. So if the valency of the element is greater than or if it is equal to 2, such elements are capable of forming this property called as catenation. Secondly, the condition for catenation is they should have an ability to bond with themselves. That is, carbon can bond with itself as a long chain of carbon atoms. So this property is one of the property conditions for catenation to take place. Thirdly, the self bond must be strong. The carbon-carbon bond that is being formed, or the silicon-silicon bonds that are being formed in the property of catenation, they should be strong enough. And lastly, the kinetic inertness of the catenated compound towards other molecules. They should have the kinetic inertness. Inertness means they should not be reactive. So kinetic inability of the catenated compound towards other molecules. All these four conditions will be the conditions for catenation to take place, which is exhibited by our carbon group. There is another property exhibited by our carbon group, which is called as allotropy. Allotropy is a property in which two or more physical forms is exhibited by the elements, but all of them, they have similar chemical properties. So elements exhibiting two or more physical forms but having the same chemical properties, the phenomenon is called allotropism and the property is called allotropy. Carbon exhibits various kinds of allotropes. The various allotropes of carbon are diamond, graphite, fullerenes, carbon nanotubes and graphene. These are all different in their physical forms, but most of them have similar chemical properties. Let us see diamond and graphite. All of you are aware of diamonds and graphite. Both of them are allotropes of carbon. That is, they are different to look at, different structures, different physical properties, but all their chemical properties are the same. You have seen the black colored, soft, breakable graphite, which conducts electricity. Whereas you have also seen a small speck of diamond giving us beautiful light. Both of these, when burnt, they produce carbon. So let us see some of the properties of diamond and graphite. Diamond is very hard substance, whereas graphite is very soft. Diamond is tetragonal in structure, containing 4 carbon atoms, and graphite is hexagonal shaped, having 6 carbon atoms. Graphite is the most stable allotropic form of carbon at normal temperature and pressure. It is also soft and it can conduct electricity. It is the carbon atoms present is sp2 hybridized, whereas in diamond it is sp3 hybridized. This will be the structure of a tetrahedral carbon atoms in diamond molecule, and in graphite they are hexagonal and planar in nature. The carbon-carbon bond is 1.54 in a diamond molecule, whereas in graphite it is 1.40 angstroms. There are no free electrons in diamond and hence it is a non-conductor, whereas in graphite it can conduct electricity because of the presence of the pi electrons. And graphite, they can break easily and they can be used as a lubricant, whereas diamond is a hardest substance which is even used for cutting rocks, glasses and very hard materials. A newly synthesized allotrope of carbon are the fullerenes, carbon nanotubes and graphene. Unlike graphite and diamond, these allotropes are discrete molecules containing more number of carbon atoms like carbon 32, carbon 50, carbon 60, carbon 70 and so on. These molecules have cage-like structures. In fullerenes, there are 60 carbon atoms in the form of a ball, a soccer ball, and it was found out by Buckminster. So it is named as Buckminster fullerenes, or in short as buckyballs. It is a fused ring structure consisting of 20 6-membered rings, 12 5-membered rings, wherein the carbon atoms are sp2 hybridized, and there are 3 pi bonds and delocalized 3 sigma bonds and delocalized pi bonds are present. The carbon-carbon bond distance will be 1.44 angstrom and the carbon double bond carbon distance will be 1.38 angstrom. When you talk about carbon nanotubes, these are recently developed. It is graphite-like tubes with fullerene ends. They can conduct electricity and they are used in nanoscale electronics, polymers and even in medicines. Another newly found allotrope of carbon would be graphenes. Graphenes, as you can see, they are honeycomb crystal lattice, honeycomb shaped crystal lattice structure present in graphene. They are single and has a planar sheet. It is sp2 hybridized, and in graphene the molecules or the atoms are densely packed. So all these are different types, different physical forms of carbon having mostly similar chemical properties.